Algebra 1, when we did interest, when we did the interest formula, do you ever remember seeing it? Sometimes we had it like in exponential equations, or do you ever remember seeing this interest formula for Algebra 1? We talked about it when we were doing continuous compounded interest. Okay, so you might have seen it before, but we didn't really talk about, well, what is E and what does it represent? Okay, so let's back up. Who has heard of pi before? Oh, you better all raise your hands. Okay. Here's what you know about pi. You probably know we represent it with a symbol, right? You probably know it's about, Kim, just give me 2 decimals. About what? It's about 3.14, but it's not really. If you all have a pi button on your calculator, if you would type it in, your calculator will give you more digits than that. But pi is an irrational, we call it irrational number, and what that means is it goes on in a decimal value forever, and it has no pattern, okay? So what is E? Okay, first of all, E is like, we're going to write like the number pi, or I'll give you another one. If I said the square root of 7, do you know the square root of 7 exactly? No, we don't know it exactly. Agreed? Type the square root of 7 in your calculator. Do you see kind of, not the same number, but the same deal? Do you see that I have a decimal? It stops because my screen stops. And does there look like there's a pattern here to the decimals? Like, is there repeating or anything like that? No. Okay. So E is in that same category. So it is an irrational number. And so that irrational just means we cannot simplify it to a fraction or a finite decimal or even a repeating decimal, okay? And if you did put it in your calculator, that's what we're going to do next. Let's figure out what it is approximately. You know how we say that pi is about 3.14? So E, I'm going to type it in. Do you see underneath the log key, and I'll find it on the pink ones, there's this E, and it's always raised to an exponent. And so I'm going to just raise it to the first, because E to the first, anything to the first power is itself. And I don't know if you can see that. We're going to call E about, E is approximately 2.718. All right. Do I have, let me show you on the scientific ones. There's a couple here. Let's find it here. Oh, do you see it? E is also below the log. So it's second ln, and we're going to talk about ln in a second. If you did E to the first, okay, that's what I'm talking. Okay, and you might think, well, how did it come about? Well, it has to do with when you start, one of the ways you can think of it is when you start with the interest formula, and let's say in the interest formula you compounded your interest all the time, like every millisecond of a minute of an hour of a day. What happens is that rate becomes closer and closer and closer and closer to E, so it's a limit. Without having the time really to explore what it is, that's if you wanted just a general explanation of where it comes from, that's where it comes from. E is actually named after a guy, a mathematician, named, it looks like Euler, right? It's actually Euler. So it's named after a guy named Euler, and it's called Euler's number because he was the one who discovered it. Okay. Now, You don't need to know that for what we do today. So e is also referred to the natural base, which is where this natural logarithm comes from. So the natural logarithm, which is what we're going to study today, is the inverse of this function. It is the inverse of the function y equals e to the x. Okay, so the way we can write it is, think of it as a logarithm. We're going to switch those things around. This is going to be my base. So one way we can write it is log base e of x. But in looking at your calculator, do you see log base e of x anywhere? No. Remember we talked about this is called the natural base. So the reverse of it is, now we're going to call this the natural logarithm. And so the way you're going to see me refer to it is ln, the n's kind of for natural, of x. Okay, so when you see ln of x today, that's what it is. Okay. So the base isn't written down. The base is just e, this irrational number. All right, would you find the ln button on your calculator? Do you see that it's right below the log button? Okay. So the only two logarithms that our calculator does for us was common log, which we were studying in the beginning of the week, and now natural log. All right. Just because we haven't talked about graphs before, what I want to quick show you is, just so you know the shape of the graph, we're not going to be graphing by hand. Could you guys all on your paper draw an exponential growth curve? And if you're not sure, you can wait for me. We're just going to draw an exponential growth curve. We've studied this before in multiple classes, okay? E to the x, okay, tell me this, guys. If e is 2.7, does it make sense to you that that's a growth curve? Okay, the graph of e to the x looks like this. Okay, it goes through 0, 1, and then it would go through 1 comma e, or 2.719. So, remember how I told you these were inverses, right? Do you remember with inverses we reversed the x's and y's around? Do you remember doing that? Okay, if I would reverse the x's and y's around, I'm going to show you the sketch of the natural log. So instead of sticking on the x-axis, doesn't go below the x-axis, what happens is the natural log doesn't go beyond this line. And so it's graphed like over here. So draw that graph. Make sure it doesn't go beyond here. And just for point of reference, here's the line y equals x. This is ln x. You guys did this. You did this. I know you turned in a worksheet for me. What's happening here is this is like over here. Are you seeing that inverse relationship? Okay. If you take pre-calculus next year, which some of you are going to take pre-calculus, we do graph logarithms. We make a step up when we start graphing logarithms. So I want you to just have been exposed of what the graph looks like. So, okay. So for today, when we are doing our logarithms, if we see y equals ln of x, what was the base of this again? What's the base? E to the y equals x is how we write it in its exponential form, okay? Just like every single logarithm we have done. So, if I wanted to write this in logarithmic form, I look at the base and it's e, right? So I would write log base e So if you want to write it this way, you may. You can write log base e. I'm going to write log base e like this. I don't know if you remember this, but on the other side is where we get that from. Okay. Just like before, if I have something up here, the y goes on the other side of the equal sign, and what it equals on the other side is what I take the natural log of. So if I wanted to write this in logarithmic form, this 5 is what's going to go on the other side. That's my y, okay? And it would be written as 5 equals natural log of x. Okay, let's go the other way. What if I wanted to write this in exponential form? All right, if it's natural log, what's the base of the log? E. To get the exponent, I look on the other side. So 0.7741, and it is approximately x. All right, over here, what's the base of the log? E to the other side, x equals 10. So in a moment, we're gonna, with your whiteboard, because you still, some of you have your whiteboard, we'll practice a couple of those. All right. Oof, who remembers our properties from before? I'm asking you to go back and remember properties. Do you remember how subtraction you can put together as division? We're just doing it today with a natural log, and the number in front was the exponent. All right, so I'm going to just do 2 examples where I'm putting that together with natural log. So the very first thing I'm going to do is I'm going to take this number in front and I'm going to put it in the exponent. So this would be the natural log of 10 cubed minus natural log of 8. There's no exponent there. All right. Our rule for putting logarithms or condensing it as a single log would be, I would write this as division. So on the top is 10 cubed, or if you wanted to write 1,000, divided by 8. Okay. So we already took a quiz on this when we were doing this with other bases, but today we're just doing it with the natural log. All right. Does anyone remember how I condense with addition? What operation do I use with addition? Multiplication. Okay, so for these ones, I don't have an exponent here. This, I do have an exponent. Okay, so I have the natural log of 40 plus the natural log of 1/2 squared. That was an exponent. Plus natural log of x. And now I'm going to put this all together with multiplication. So this would be the natural log of 40 times 1/2 squared, which is 1/4, times x. Can I simplify that any further? What's 40 times 1/4? 10. All right. All right. So just putting the logarithms together, I think maybe it looks like to me you might need a reminder on the different logarithms. So I'm going to put